Hello, Math 1. This lesson's on 3.A, which is solving linear inequalities. Before we get to the lesson, I want to bring you over to the side here and go through something that I feel is pretty valuable to go through before we talk about an important property of solving inequalities. Here I have a bunch of inequalities written here, and it's they all say 6 is less than 8 because we know that given statement is true. Now, if we perform operations to one side and we duplicate it on the other, such as if I add 3 to this side and I add 3 to this side, does this inequality remain true? Is 9 less than 11? That still remains true, right? And say I go ahead and pick a number and say I'm going to subtract it from both sides. So I'm going to subtract 2 here, subtract 2 here. I get 4 is less than 6. Does that remain true? Yes, that remains true. So we're good there. Now, say I multiply each side by positive, say 3. Multiply by positive 3. I get 18 less than 24. Does that inequality remain true? Yes. So that works out. But say I go and multiply by negative 3 times negative 3. That would give me negative 18 is less than negative 24. Is that true? This here is not true. But what can we do to basically make it true? Well, if I take that inequality sign and flip it, now that would become true. Negative 18 is greater than negative 24. Now, if I divide both sides by, say, 2, is 3 going to be less than 4? That checks out, right? But now, say I go and divide by negative 2. That would give me negative 3 less than negative 4. Does that remain true? No. This here is not true. So, what could we do to make that true? Well, if I take that inequality sign and flip it again, now does it become true? Yes. So what you have to understand here is when I take multiplying by a negative and dividing by a negative, and if I multiply both sides by a negative or divide by a negative, I must flip the inequality sign. Which brings us to how do we solve inequalities? Well, just like equations, simplify left and the right side of the inequality, meaning we distribute and then we combine like terms. Once that is done, we are basically going to move, right, and move the variables to the left, move the constants to the right by undoing addition or subtraction. Once I undo addition or subtraction, then I undo multiplication. But there's one little note we're going to have to add here. If you multiply or divide both sides by a negative, you must flip the inequality sign. Sorry to go in ugly territory there. So let's take a look at some examples. They want you to solve these inequalities and then graph them. The graphing and interval notation I'm going to go through pretty quickly, right? So when I look here, the first one, pretty easy. How do I get x by itself? I know I'm going to subtract 4 from both sides. X is less than or equal to negative 10. So because we're equal to, we know we're going to put a solid dot on negative 10. Less than or equal to tells us we're going to shade to the left. And when we write our interval notation, our lower bound is negative infinity. Our upper bound is negative 10. Since we're equal to, we're going to use that square bracket. Now, anytime an inequality, right, is written like this, I like to rewrite it where I put x minus 4 on the left, 6 on the right, and I have to keep the alligator eating the 6. So now I can go ahead and solve this inequality by adding 4 to both sides. X is less than 10. Because I'm strictly less than, I'm not equal to, I'm going to put an open dot on 10. Because I'm less than 10, I'm going to go ahead and shade to the left. Right away, I know my lower bound is negative infinity. My upper bound is 10. So it's going to go from negative infinity to 10. I'm going to put a round bracket on 10 because I'm not equal to. Okay. Next one. Divide by 7, right, is what I would do to solve. Because I'm dividing by a positive, right, I do not have to flip the inequality sign. So my solution is x is greater than or equal to negative 8. Because I'm equal to, I know it's going to be a solid dot on negative 8. And if I'm greater than, all the numbers greater than negative 8 are to the right. For my interval notation, my lower bound is negative 8. My upper bound is infinity. Because I'm equal to, I'm going to use a square bracket, negative 8, comma, infinity, round bracket. Okay. Number 4. Now, here, I'm going to go ahead and divide by negative 9. Because I'm dividing by a negative, I know x, I must flip that inequality sign now. X is greater than negative 7. So now I know I'm going to have an open circle on negative 7. And I know I'm going to shade to the right. Okay, now my lower bound is negative 7. My upper bound is infinity. So I know I'm not including negative 7. So round bracket negative 7 to infinity, round bracket. Now the next example, right? Again, no different than solving an equation. First thing I'm going to do, I'm going to go ahead and subtract 5. Right, that's going to give me 4x. Bring down the less than or equal to sign, then 8. Now I know I can divide both sides by 4. X is less than or equal to 2. So I know the equal to tells me to put a closed dot on 2. Because I'm less than or equal to, I know I'm going to shade left. And my interval notation, lower bound, negative infinity, comma, 2. And I'm going to use a square bracket because we're including 2. All right. Now, next, right away, I know I'm going to go ahead and, in this case, add 19 to both sides. That gives me 7x is greater than 35. Now, I'm going to go ahead and divide by 7, and I would get x is greater than 5. So we put an open dot on 5. Since we're greater than, we would go to the right. Lower bound here is 5 with a round bracket, because we're not including it, to infinity. So in the next example, right? First thing I'm going to do is get x by itself. This is a little trickier. Now, I know I have to get rid of 16. Since 16 is positive, I'm going to go ahead and subtract it, right? That's going to give me negative 2x is greater than or equal to negative 8. A lot of people will forget to bring down negative 2x. Now I can divide both sides by negative 2. Because I'm dividing by a negative, I must flip that inequality sign. So x is less than or equal to negative 8 divided by negative 2 is positive 4. Since I'm equal to, I'm going to put a closed dot on positive 4. And if I'm less than or equal to, I'm going to shade to the left. Lower bound in this case would be negative infinity. Upper bound is 4 with a square bracket because I'm equal to. Now number 8. the first thing I want to do here is get rid of a fraction. How do I get rid of that fraction? Multiply both sides by the denominator. That cancels the denominators out. What am I left with on the left? X plus 2 is less than negative 8. Now, I can go ahead, subtract 2 from both sides. X is less than negative 10. I'm going to go to negative 10 on the number line. I'm going to put an open circle. I'm going to shade left. Interval notation, my lower bound is negative infinity. My upper bound is negative 10. Since I'm not equal to, round bracket. Number 9. Right away, to get x by itself, first thing I do, add 10 to both sides, right? Gives me negative 1/8 x is less than or equal to negative 6. Now, there are many different ways that you can approach this problem from here. You can multiply by the reciprocal and this and that. Now, I like to multiply both sides by the denominator. That cancels the denominator out, leaves me with negative 1x is less than or equal to negative 48. Then I can go ahead and divide both sides by negative 1. But because I'm dividing by a negative, I must flip, right, that inequality sign to greater than or equal to positive 48. So if I take this number line out and I start at positive 48, I know it's going to be a closed dot, and I'm going to shade to the right. So that would be square bracket 48, comma infinity, round bracket. Now, number 10, I'm going to do two things at once. The first thing I'm going to do is simplify the right side. And I'm going to go 4 times 7x is 28x. 4 times 3 is plus 12. Then I'm going to bring the 8 to the right side. But that alligator is eating 8, so I'm going to keep it eating 8. Now I can go ahead and easily solve this inequality. Subtract 12. 28x is less than negative 8 plus 12 is negative 4. And if I divide by 28, I get x is less than negative 4 over 28, which is x is less than negative 1/7. And that's because negative 4 over 28 will simplify to negative 1/7. Both can be divided by 4. So negative 1/7 is going to be in between 0 and negative 1. It's actually be closer to 0, where we'd have an open dot at negative 1/7. We're going to shade to the left. That would give me interval notation of lower bound negative infinity, upper bound negative 1/7. We're not equal to, so it's a round bracket. Now, with inequalities, when it comes to graphing and solving, I'm going to tell you right now, I find it easier to move the variables to the left and constants to the right. So for this first example, the first thing I'm going to do is subtract 4x from both sides, align like terms. Then I'm going to subtract that 1. That gives me negative 1x is greater than 6. But now, to get rid of that negative 1, I'm going to go ahead and divide by negative 1. And when I divide by a negative, I must flip that inequality sign. So this flips and becomes x is less than negative 6. So negative 6, I'm going to put an open dot. Less than means I'm going to go to the left. My lower bound for interval notation would be negative infinity to negative 6, not including it, so round bracket. Number 12. First thing I have to do is simplify this left side. 2x minus 6 plus 2. If I combine like terms, this is going to be 2x minus 4 is greater than or equal to x plus 5. Now, from here, I move my variables to the left, my constants to the right. Notice all my like terms are aligned. So 1x is greater than or equal to 9. So x is greater than or equal to 9. Equal to 9 tells me close dot. Greater than tells me I shade right. And my lower bound here is square bracket 9 to infinity round bracket. And the last one here. To solve this, I simplify the left side first. 4x minus 9 plus 3x. Remember, when I distribute, negative 3 times 3 is negative 9. Negative 3 times negative x is 3x. Combine like terms, I get 7x minus 9 is less than 9x minus 5. So this side simplified to this, and then I brought this side down. So now, subtract the 9x, align like terms, add the 9, negative 2x is less than, negative 5 plus 9 is 4. Now I can divide both sides by negative 2, and when I divide by a negative, flip the inequality sign, and you would get negative 2. I know it's going to be an open dot on negative 2. I'm going to shade to the right because I'm greater than, and my lower bound would be negative 2 to infinity. Go ahead, try the student practice, and let me know if you have any questions.